Hello everyone, welcome to another video tutorial all about variation. Our most essential learning competency for this topic is to illustrate situations that involve the following variations. We have the first variation, direct variation, second, inverse, third, joint, and the last type of variation is combined variation. Let us first define what is a variation. It is a change in form, position, condition, or amount of something. Regarding the four types, we are going to begin with the first type, which is the direct variation. As one variable increases, the other one also increases. So that is the major definition of direct variation. From the word itself, we have direct. Therefore, when one quantity increases, the other will also increase, as well as when the other variable decreases, the other one or its partner will also decrease. So the expressions that express direct variation are the following. We have y varies directly as x, and y is directly proportional to x given that we have two variables, y and x. For the representation, we have here y equals kx, wherein k or small letter k is the constant of the variation. From the word itself, constant, it will not be changed. That's why it's constant or fixed. So for the equation of the variation, it is also expressed as y equals kx, wherein k should not be equal to 0 or the constant should not be equal to 0. So let's move forward with the translation. So we have three to translate. We have statements, table of values, and graphs. Beginning with the statements, we have P varies directly as Q. If we are going to find or use the pattern y equals kx, and then we have here the clue word or the expression that denotes direct variation varies directly. Therefore, we have to use y equals kx. So for the variables, we have p and q to replace y and x. So p now will be the value of y. So p equals, and then write k because this is constant and fixed. No need to change the variable, it's k. And then the other variable to replace x, which is q. Therefore, our translation of this statement is p equals kq. Next, for number 2, we have the cost C of meat varies directly as the number N of kilos bought. So we have here the relationship between the cost and the number of kilos. So the cost is represented by the variable C, and then we write the equal symbol, and then we write a constant K, and then the other variable, which is N. So we have C equals Kn. Third example, for the statements, we have the weight W of an athlete is directly proportional to his height. So we will have W equals KH. So this will be our translation. Now that we are done with translation of statements, let us move on with the translation of the table of values, or identifying if the table of values shows direct variation or not. So we have here values for x and y in our table. For the values of x, we have 6, 7, and 8. For the values of y, we have 12, 14, and 16. Since based on the direct variation description, one quantity increases, the other quantity must also increase. So we are going to analyze if these values for x and y are increasing or decreasing. So for the values of x following the order 6, 7, and 8, we can say that these values are increasing. While on the values of y, we have 12, 14, and 16, we can also say that this one is also increasing. So if the table or the values for x and y goes like this, one is increasing and then the other one is also increasing, therefore there might be a chance that this one represents direct variation. But we have to verify using what we call the common ratio. When the table of values expresses or has a common ratio, therefore it is a direct variation. So let's fix this one. So common ratio. And for us to find the common ratio, just write 6 over 12 as the first fraction based on our table of values, that's x over y, might be equal to 7 over 14, another ratio or another fraction, equal to 8 over 16. When we simplify or get the lowest term of 6 over 12, 7 over 14, and 8 over 16, we will arrive at 1/2. So as you can see, the ratio of these fractions is 1/2, and they have a common ratio. And when they have the common ratio, therefore, this represents a direct variation. We can also check for the common ratio or if it is a direct variation table using cross multiplication. So that is another method. Just write the values again. We have 6 over 12 equals 7 over 14 equals 8 over 16. Following cross multiplication, we multiply 7 times 12. The answer will be 84. And then we also multiply 6 times 14. That will also give us an answer of 84. So as you can see, we have the same product. Therefore, this one is correct. And then for the last cross multiplication, that's 8 times 14. It will give us 112. And 7 times 16, it's also 112. So as you can see, we've got the same numbers again. So that is another way on how to find out if it represents a direct variation. So now that we are certain or sure that it's a direct variation, we are now ready to find the equation of the variation. So the equation of the variation is based on our translation y equals kx, since we have two variables x and y, or y and x. So for us to find the value of the constant, we simply get one pair of values from our table of values. So the first value of x, that's x sub 1, and then yung 7, that will be x sub 2, and then 8 will be x sub 3. And then for the values of y, we have y sub 1 is 12, y sub 2 is 14, and then y sub 3 equals 16. So the sub denotes the order or the number or the place of those numbers in x and y. So just get one partner or one pair. So you can use x sub 2 and y sub 2, or x sub 3 and y sub 3 as long as they are pairing. So I will be using the first givens. So we have x sub 1, which is 6, and then y sub 1 equals 12. I will be using this given to obtain the value of k. So using this formula, substituting our given values or our values from the table, this will be y, which is 12, equals k as it is since it's missing, and then the value of x is 6. So 6 times k, it's 6k equals 12. Divide both sides by the number beside the variable for us to eliminate that number and arrive with the variable itself. K equals 12 over 6, and 12 divided by 6, that's 2. So the value of k here is 2. Now that we have the value of k, we can simply substitute it in our equation of the variation y equals kx. So this will be y equals 2x. So this one is our final answer. Moving on with our next example for the table of values. We have here the distance in kilometers and the time of flight in minutes. So for the given values on distance, we have 160, 320, 180. For the given in time, we have 20, 40, 50, and 60. So analyzing the given values, if they are increasing or decreasing. For the distance, we have 160, 320, 400, and 480. These values are increasing. While on the second values, the time, we have 20, 40, 50, 60. This is also increasing. Knowing that one value increases as the other also increases, therefore, this might be a direct variation. So let's find out what is our common ratio. So for the common ratio, you can simply divide 160 divided by 20. So that will be equal to 8. 160 divided 20 is equal to 8. as well as 320 divided by 40 will give us 8. The next 8 also, and then the last one, we also have 8. So we have the common ratio, which is 8. Now that we have the common ratio, we are now ready to define that this is a direct variation table. After that, we find the equation of the variation. So I just write EQ of variation stands for equation of the variation. And then we find the values. So for this one, since we have here no variables, we can represent the distance as d, and then we can represent the time as t. Or otherwise, you can use x and y for the values of distance and the time. So following that, this will be t equals kd. So this is now our translation. And then we get some values from the table. So I will get the first values. So x sub 1 or d sub 1, I will write d sub 1 equals 160. And then we have k sub 1, which is 20. And then we are looking for the value of k. Substituting in our formula, this will be 20 equals k multiplied to d, which is 160. We divide both sides by the number beside k, which is 160. So we have 20 over 160, which is also equal to 1/8 in its lowest term. So k is equal to 1 over 8. So this will be our constant. Now for the equation of the variation, that will be t equals 1 over 8d. So this is our final answer. Next, we have here the pressure in Pascal, and then we have the volume in cubic decimeters. Analyze the given values. 1, 2, 3, and 4, this one is increasing. While on the other value, so for the volume, we have 42, 21, 14, and 10. We can say that these values are decreasing. Knowing that one value increases and then the other decreases, therefore, this is not a direct variation. Later on, we are going to find out what type of variation gives us a quantity that is increasing and then the other that is decreasing. So let's proceed with the graphs. So for the graphs, we have here the regular shape of a graph for direct variation, which is a straight line. Given example number 1, we have here t as our value for the x or x-axis. That denotes the time. So let us list down. So that's the value of x, t, time in hours. And then for the values for y or in the y-axis, we have d or capital letter D. That denotes distance in miles. So those are the values of y since they are on the y-axis. So let's list down all the given points or ordinates of the points in this table. So we have here for the first time 1 hour, that is equivalent to 30 miles, 2 hours 60, 3 is 90, and then we have here 4 is 120. So now that we have it here, so as you can see, the values in t is increasing, values in d is also increasing. Therefore, this might be a direct variation. Now for the common ratio, 1 over 30 in its lowest term is 1 over 30. 2 over 60 in its lowest term is also 1 over 30, as well as the others. 3 over 90 is also 1 over 30. And the last one, 4 over 120 is also 1 over 30. So the common ratio is 1 over 30. Therefore, this is a direct variation, or the graph represents a direct variation. Now that we are certain that it is a direct variation, let's go with the equation of the variation. Again, just pick values from the table. So for our translation, since we have here d and t, so we will have d equals kt. And then for the values, let's have t sub 1, which is 1, and then d sub 1, which is 30. d sub 1, 30, is equal to k multiplied to t sub 1, which is 1. Dividing both sides by the number beside k, which is 1, k will be equal to 30 over 1, or 30. Therefore, for our equation of the variation, this will be d equals 30t. This is our final answer. Okay, so let's move forward with solving for the variables. Beginning with example number 1, the cost C of chicken varies directly as its weight W. Find the equation of variation and the constant K if C equals 460 and W equals 4. Establishing the relationship in the problem, we have the cost of chicken varies directly as its weight W. This will be C equals KW. We'll list down all the given values in the table or in the problem. So this will be C equals 460, and then we also have W, which is 4. And then we are looking for the value of K and the equation of the variation. Substituting our given values, we will have 460 equals K, which is missing, and then W, which is 4. K times 4, we will have 4K equals 460. And then divide both sides by 4 for us to find the value of K. So 460 divided by 4 will give us an answer of 115. Therefore, the value of K is 115. For the equation of the variation, we just have to substitute the obtained value of K on our translation a while ago. So this will be C equals 115W. We move forward with our second example. The water pressure P varies directly as the height h of the water. If P equals 340 and K equals 5, what is h? So water pressure is P equals KH. Given values, we have P equals 340, K equals 5, and then we are looking for the value of h, or the height. So we will have the substitution, 340 equals 5 multiplied to h, or 5h. Divide both sides by the number beside the variable, which is 5. So we will have 340 divided by 5, 68. So the value of h, or the height, is 68. We move on with number 3. The weight W of pure water varies directly as its volume. If B equals 16 and K equals 9, what is W? Translating that, this will be W equals KV. Given values, we have V equals 16, K equals 9, and then we are looking for the value of W, which is the weight of pure water. Substituting the values, we will have W equals 9 multiplied to 16. Multiplying 9 to 16, we will have the answer, which is 144. So the value of W, which is the weight of pure water, is 144. Fourth example, we have if y varies directly as x and y equals 48 when x equals 16, find y if x equals 30. So if you will notice on the given problem, we have two sets of x and y's. So if you are going to translate y varies directly as x, it's simply y equals kx. For the value, since we have two sets, we write the first value of y as y sub 1, since it's the first given value of y. So y sub 1 equals 48, and then x sub 1 is 16. And then we are asked to find the value of y, or y sub 2, if x sub 2, or the second value of x, is 30. First, we are going to find the constant using our first set of given. We establish another formula with the sub 1s. So this will be y sub 1 equals k times x sub 1, and then we substitute the given values on our first set. So this will be 48 equals k multiplied to 16. And then we divide both sides by the number beside k, which is 16. 48 divided by 16 will give us an answer of 3. Therefore, the value of k here is 3. Now we are ready to solve for y sub 2. So y sub 2 is equal to, so we have k times x sub 2. And then substitute the given values. This will be y sub 2 equals 3 multiplied to x sub 2, which is 30. 3 times 30, that is 90. So the value of y sub 2 now is 90. Next, for number 5, the electric current I in amperes in an electric circuit varies directly as the voltage V. When 24 volts is applied, the current is 8 amperes. Find the current when 12 volts is applied. So we have here the electric current represented as I, and then we have electric circuit, and then we have the voltage represented as V. So if we are going to translate this will be I equals KV. And then for the given values, we have two sets also. 24 volts is V sub 1. And then 8 amperes is our first electric current, that's I sub 1. And then we are looking for the current, or I sub 2, when the applied volts is 12. So V sub 2 is equal to 12 volts. Now we solve for the value of K first. So we will have I sub 1 is equal to K multiplied to V sub 1. I sub 1 is 8 multiplied equals K multiplied to 24. We divide both sides by the number beside K, which is 24. So 8 over 24 in its lowest term is 1/3. Therefore, the value of the constant is 1/3. Now for the value of I sub 2. So I sub 2 is equal to K times V sub 2. I sub 2 is equal to the obtained value of K, which is 1/3, multiplied to V sub 2, which is 12. Multiplying a fraction and a whole number, this whole number is understood as 12 over 1. So multiply numerator to its numerator, 1 times 12, it's 12. Denominator to denominator, 3 times 1, it's 3. 12 divided by 3 is equal to 4. Therefore, I sub 2 is equal to 4, or 4 amperes. And we are down with our last example. If A varies directly as B and A equals 1/2 when B equals 9 over 2, find A when B equals 8 over 3. If you will notice on our given, we have here fractions. So let us translate A varies directly as B. So this will be A equals KB. And then for the given values, we have A sub 1, which is 1/2. We have B sub 1, which is 9 over 2. And then for the second set of given, we have A sub 2, which is missing, and then B sub 2, which is 8 over 3. So we are looking for the value of K first for us to find the value of A sub 2. So this will be A sub 1 is equal to K times B sub 1. A sub 1 is 1/2, and then copy the equal symbol as well as K, and then B sub 1 is 9 over 2. We divide both sides of the equation by the number or the fraction beside the value of K, or K variable. So that's 9 over 2 for us to cancel this out and simplify. So K now is equal to 1/2 divided by 9 over 2. If we are going to divide, we make sure that we get the reciprocal of the denominator and then we proceed with multiplication. So the reciprocal of 9 over 2 is 2 over 9. And then we proceed with multiplying. So 1 times 2, it's 2. And then 2 times 9, it's 18. And 2 over 18 in its lowest term is 4. Therefore, the value of the constant is 1 over 9. Now that we have the constant, we find the value of A sub 2. So A sub 2 is equal to K times B sub 2. A sub 2 as it is, and then the obtained value of K, which is 1 over 9, and then B sub 2, which is 8 over 3. Now we simply multiply. 1 times 8, it's 8, and then 9 times 3, it's 27. So we know that A sub 2 is equal to 8 over 27, and 8 over 27, it's already in its lowest term. So that will be all for the discussion of direct variation. Hope you learned something from me today. Thank you and God bless everyone.